Alright, so I decided to fire up the camera here and show you guys something that was passed on to me by someone that's been helping me out for a while with casting. I've been casting these 405 grain. It's from an NOE mold. It's a 460, 405. I think it's a round flat. Yeah, round flat mold. And I've been gas checking these, and I have a mold from MEHEC or MP molds. It's a 462 gas check hammer, and I ordered these. These are Sage's checks. They're a 45 caliber check. Sage also sells a 458 caliber check, which now I found out is probably the correct check for these. These are for 45 caliber under, I think, 457 or something along those lines. I might be incorrect with that information, but it's something along those lines. Whereas these checks aren't thick enough, I believe, to crimp properly onto the shank on this bullet. So I put a line on here so you guys can kind of see on the check right here what's going on, and hopefully I can get you. So a lot of these checks, what they're doing is when I'm seating them, they're not crimping 100% and they're not crimping very firmly. So the gentleman that's been helping me suggested maybe I should try annealing these checks and see if they crimp better. So that's exactly what I did as per his directions, and the checks come out a little charred, but I know it's hard to see the color, but if you can see them, they look like they're kind of annealed. I forgot to grab some of the ones that are actually annealed that aren't on the base of a bullet yet. But these, it's actually cleaning the base of the bullet up where it's flat now, whereas the other ones kind of have like a little dimple in them still. Hopefully that thing focuses. I've always had problems with this thing focusing. I mean, that one's not too bad, but usually there's a little dimple right in. Well, this one's got it. I can feel it on it, but I don't know if you'll see it. It's got a little dimple in the center. Whereas these, I've done probably about 25 of these. The base is as flat as the bullet base. So if you have a little pop-up from the sprue cut, it's going to give you a little pop-up on here. So I really wanted to show you guys how I was directed to anneal these gas checks. And I got my camera in the wrong spot again. So the gentleman suggested that I take my lead pot and heat it up to temp and put a ladle in it. So I have vice grips on my ladle sitting up in there, and I realized yesterday if I put a tiny little bit of lead inside that ladle, like just enough to get a little, maybe like a quarter size area in there, it really speeds up the process, and it helped me a lot. So his suggestion or direction was take gas checks, and right now I have 100. This is going to be the largest batch I've done, and take a piece of tin foil and a piece of paper, and all you're going to do is make pretty much like a little packet out of the tin foil. And I didn't do it as he directed. I think he more or less meant make like a package out of it, and I've just been throwing them in the tin foil, kind of just like this, throwing the paper on top and just folding the edges over. And I kind of fold the paper like a ribbon just because it makes it a little easier to keep it contained as I'm folding the tin foil over. And I'll fold the tin foil, make sure the ends are sealed, so God forbid that ladle goes in the lead, you don't lose all these gas checks. And I keep just kind of rolling it back in on itself to kind of make a nice little packet. And my pot right now is about 788. And all you do is you pretty much take this little guy, and I'll get it about to the size where it'll fit in that ladle pretty well. You know, just keep working it by hand, get it into kind of a little ball shape, more or less. Oh, maybe that's not too. It is too big actually. 100 checks might be too big. The last one I did was 50 checks, and that fit in the ladle perfect in the tin foil. So maybe this is just slightly too big. There we go. We'll see if it works. So the piece of paper's in there to reduce the amount of oxygen being consumed in the package, because oxygen obviously leads to oxidation on the copper, and copper will oxidize fairly quickly. The tin foil is, I guess, to shield it from the oxygen as well as contain everything in the ladle so you're not spilling over. That I'm not positive on. From my research, I believe copper anneals somewhere between 700 and 800 degrees. I forget the exact number, but I know it's somewhere around there. So I'm trying to run my pot at 790. Now I also have the pour spout closed off because this thing's a lead drip-o-matic, and it had a beautiful piece of drip art earlier today from my run last night. So I just closed it off today. I was going to let it do the drip art, but I don't feel like dealing with the lead. So this one here with the line on it, the shank size here after it's been sized with alignment H&I sizing die and lube with homemade lube. This part right here usually sizes 4580. So it's 458 thousandths and 0.10. Ah, crap! I can't remember how to say it. I'm sorry. 10 thousandths, 0.10 thousandths. The check itself has a little bit of spring back and ends up being 0.4583. The annealing process is supposed to help with that spring back and keep it from doing that so it actually crimps on well. These checks that I did not anneal, I don't have a problem with them pulling off the base. I don't have a problem with them moving up and down like this way. I have a problem with them rotating. And from my understanding, when you crimp a check on, it's supposed to be solid on that bullet. You shouldn't be able to grab it and rotate it at all. Like some of these, I can literally take my thumb and rotate. That's how loose they are. And what I have to do in that scenario with not annealed checks is go down in the sizing die again, put a lot of pressure on the handle, which I don't like doing. And I think it obturates the base of the bullet enough, or it kind of forms the gas check to the base of the bullet enough where it actually stays on the way it's supposed to. But that doesn't always work. In this case, I did that 3 times, and as you can see, it's still moving. So, these guys, so far out of the 5 I've done, I'm going to do another 50 tonight, because I have no problem with being confident in the fact that these are going to stay on, because usually it's every single one that's not annealed. It ends up rotating, and I have to put a bunch of pressure on it. And I don't mind the look of that. I'm sure you could probably put it in a tumbler or something like that and get it to, I mean, it's just barely dull. Any of the black soot that was on there was probably from the char paper. I could wipe it off with my finger. I'm sure you could put them in a tumbler. I'm not sure if that would work harden them. That's why I didn't put these in a tumbler or anything else. I don't want to work harden them again. I know heat builds work hardening. I just don't know how much or how much deformation of the metal would cause that. It's not like I'm trying to press new checks and work hardening them in that sense. It's the heat that worries me. It might be a worry for no reason, but I still don't want to take the chance. I don't mind how they look. I'm sure they'll shoot just the same. There's no buildup on the inside of the cup where it would deform on the base of the bullet because of the buildup. So, I wanted to pass this knowledge along because I thought I had a 900 count of gas checks that would be like this and lead to accuracy issues and possibly gas check obstructions in the barrel or something goofy going on and cause leading or just any kind of issue that could be caused from the gas check, and I don't know all the possible issues, to be honest with you. I'm glad I didn't have to chuck 900 gas checks. All I have to do is anneal them, and I have no problem doing that. If I can do a 100 round batch like this, I'll do 100 at a time, and whenever I come out here to cast, I'll throw some more in and just keep doing them until I have them all done, which shouldn't be very long. It's 9 times, and I cast probably 9 times a month. So the big thing is the gentleman suggested putting them in the pot for 20 minutes. Last night, I think I went for a little bit longer than 20 minutes. I didn't exactly time it. I started at probably 12 o'clock. The pot was up to temperature rather at 12 o'clock. And I think I ended up throwing them in the pot at like quarter after 12. And then it was probably like 5 after 1 before I actually got back out here to pull them out. And they were annealed. So long as your pot maintains about 800 degrees or just below, I don't think it'll cause too much issue. I don't think it's the length of time that'll damage them. I think it's more or less going over a certain temperature to anneal them or staying under a certain temperature to anneal them that'll hurt them. I'm hoping this 100 round works. Hopefully it does, and I'll make another video showing you what they end up looking like after they come out of that pack. Or really, I guess maybe I can make a video of opening that package just to show you. But I wanted to pass this information on because that's kind of how knowledge works. If you don't pass it on, it gets lost. And I found this to be ridiculously easy. and something that I don't believe I've seen or heard mentioned before. I may have missed it, or I may have heard it and forgot it. But this is something that's very valuable, especially if you're sitting on a bunch of gas checks that don't fit a bullet shank and they're just loose like that and not falling off. You could probably try annealing them in a small batch and see if they work. And if they work, you didn't waste $40 on gas checks. So hopefully I'll be back in a little while and we'll see how everything's going, and hopefully it came out alright.